Hollow structural steel sections are very common these days. They are very versatile, they are quite efficient at carrying load, and they make beautiful structures. These members are generally fabricated in workshops from thin rolled steel plates and then transported to site as either individual members or as prefabricated sub-assemblies. Since the walls of these members are thin, they can easily get damaged during transportation and handling. Damage can occur during loading and offloading, moving the members from one location to another, or during final erection into place on site. Damage usually occurs in the form of dents, which can be caused by equipment such as forklifts, or when members are dropped from heights, or tools are dropped on the members. When such damage happens, the question then becomes, can the damaged member still be used or not? And the answer should be, well, it depends on how bad the damage is. But if we look at the codes of practice that govern the fabrication of steel members, they don't give any tolerances for damage. Most of them, including our own SANS 2001, tell you that you should not have any damaged member, and if you do, you should send it back to the factory. It's only the Australian standard that allows you to use a damaged member if you can demonstrate that it can still carry its intended load. Sending back an individual damaged member might not be such a big deal, but when a member is part of a sub-assembly, then the whole sub-assembly has to be sent back to the factory. And without knowing whether the member's load carrying capacity is significantly affected by the damage, sending back a whole sub-assembly might be unnecessarily wasteful, which will just result in increased cost and cause unnecessary delays on the construction project. And so for my project, I used nonlinear finite element analysis to find out the effect of dent damages on the load carrying capacities of hollow structural sections. My project specifically focuses on the buckling strengths of some commercially available square hollow sections, circular hollow sections, and rectangular hollow sections. I do this by comparing their undamaged buckling strength to their buckling strengths at varying degrees of damage. So, based on the results from the set of members that I have studied, there are many instances where even the highest level of damage did not cause a significant drop in the buckling strength of the members. There are many cases where members retained more than 90% of their undamaged buckling strength, meaning it is possible to tolerate some damage on hollow sections.